Sorry. So I'm going to do a presentation on the constellations for you, a little bit of a background on the history of the constellations. So these are things I'll cover basically, a bit about the origins and history, a bit of mythology, which I love, the Zodiac constellations, a little bit about those, and then how the constellations work for astronomers today, and also a little bit about asterisms. You know that word you come across every now and then, you think, what the hell is an asterism and what is it in relation to a constellation? So I'll try and explain a bit about that. And then finally I've got a little section on astrophotography, but not astrophotography with a CCD or more complex astrophotography. It's just a simple astrophotography with a camera, even though when you see the notes you probably think, how is that simple? I won't go through all the notes, but it's basically just as it always has been, with a tripod and a camera, and I'll talk to you about that later on. So one of the things, the word constellation, forgive me, indulge me for a moment because I love Latin. So constellation comes from the word, if you see co in front of the word, it's a Latin, it comes from Latin cor, which means with or together. So all these words in the English language, about a third of them are all derived directly from Latin, by various means, even though English is a Germanic language, it doesn't matter. So they've crept in through the Norman occupation of England, through Roman, Christian times and so on, into Middle English and then into the modern day. So the word, if you see that in front of it, it means together or with. So stella is the Latin for star, and so is the word aster or astra, hence asterism, asterisk and all that sort of thing. So constellation comes from that, a group or gathering together of stars. And there are various definitions. Can you actually see that from back there? I mean, it doesn't matter if you can't read it. I'm trying to make it a little bit bigger. It's about as, I'm sorry about the small font, but I got obsessed with getting everything down. So basically, there are various definitions of constellations, but Britannica says any of a certain groupings of stars were imagined, at least by those who named them, from conspicuous configurations of objects or creatures in the sky. Constellations are usually named after an animal, a character from mythology, or a common object. And sometimes, an actual person, as in Hercules, for example, heroic hero, heroic from Greek mythology. In 1922, the International Astronomical Union officially recognised that there were 88 modern constellations. But we're going to look at the Greek ones first. There were 48 of those, and we'll look at how they were derived briefly. But the first real people to sort of look at constellations in any detail were the Babylonians, which we're going to come across shortly. And from Babylon, all of that information, I'm truncating this a bit, but all of that information from Babylonian astronomy filtered through to the Greeks. Eudoxus was one of the characters, Aratus and Hippocrates, and then, Hipparchus, not Hippocrates. And from Hipparchus, information was passed through to Ptolemy and his Almagest. So that's kind of a rough chronological order of things, but I've simplified it. Now that's Western. They're the Western origins. Of course, other civilizations, India, China, had their own constellations, as we'll see. So basically, I've collapsed a lot of that information there. Things date back to the early Bronze Age. So what's really interesting is that the original purposes of these constellations, as are observed, were either religious or agricultural, and so they helped people to start farming at certain periods. You'll see the Egyptian civilization, or they marked the beginning of different seasons. So we'll look at that too. Sorry if I'm going so fast. Gee, I wish I could see these arrows. Oh. Right. Here's a beautiful example. Did you know the ancients had globes? Now, I didn't know this, but they did. They actually had celestial spheres with constellations on them. And so there are three that have survived to today that we have here. There's this one. Now, this is the Farnese Atlas, a statue of the god Atlas, who was a titan, not a normal god, one of the originals. And he had the globe of the earth. Instead of the globe of the earth, he's got the celestial sphere on his shoulders, and this is probably dates back to sometime between the 1st and 2nd century AD. And all of these things that you see before you, the mains globe down here, comes from Roman Egypt. Now, how did all this happen? Because the Greeks were in Egypt before the Romans, and so these early Greek astronomers got their information, probably filtered through from Babylonian civilization, as I said earlier, and that information was transferred to the Romans too, and they created these marvellous globes with actual constellations on them. The Kugel globe, these are all in museums today, named after the people who either put them in the museum or who own the museum, dated around 300 BC, found in eastern Turkey, only 6.3 centimetres in diameter, made of gilt silver. I'm sorry if you can't read that, that's why I'm reading it to you. The Mainz globe, now Mainz is wonderful, it was a German, sorry, I love my Roman history, it was a part of the Roman frontier, and Mainz has got a beautiful museum in it, which I want to go to one day, a lot of Roman artefacts in there. And so this is where the globe is located, the Mainz Museum, believed to come from 2nd century AD Roman Egypt. So when the Romans occupied Egypt really from 48 BC onwards. So we're well acquainted with the Greek knowledge of astronomy by then. The majority of the 48 constellations depicted on the globe correspond with those in Ptolemy's Almagest. Now Ptolemy was 2nd century AD, so Ptolemy got all his information probably from the guy we mentioned earlier, Hipparchus, who had them from the other Greeks, Aratus and Eudoxus, who got their information from the Babylonians. Does that make sense? Bit of a rough sequence. So these globes are amazing. And in Indian civilization over here, that word, nakshatras are the 27 or 28 lunar mansions. So they had names for the stars too. And we're not going to go into that because we haven't got time. But it is interesting to see that they had those, that they had their own names for these constellations as well. Back to the Farnese Atlas, 42 of the 48 constellations are depicted on there, including Aries, Cygnus and Hercules, which are visible on the, quite clearly visible on the actual sphere. All right, we'll move right on. Now, oh, I love this. I used to teach Egyptian civilization as well as the Roman, but one of the things that interested me was the tomb of Senenmut. Have you ever heard of a man called Senenmut? He was Hatshepsut's lover and also chief architect and vizier. And he looked after her. Hatshepsut was an 18th dynasty queen in Egypt. In the New Kingdom period, which is when Egypt really expanded and had an empire. And Hatshepsut, has anyone been to Egypt?
Yeah.
You know the temple of Hatshepsut? That's her mortuary temple. There were different kinds of temples in Egypt. A mortuary temple was designed to commemorate a particular pharaoh. Now, because she was female, she had to strap down her breasts and wear the ureus, the royal beard, and pretended she was a guy. Very difficult to do in a culture which was totally male. You couldn't have a female pharaoh. But she was a very good pharaoh, as it turned out. Anyway, this fellow was buried in the Theban, there's a place called the Valley of the Kings. I don't know if you know about it or you've heard about it, where all the pharaohs are buried. As you drive along, do a dog leg to the right, and you get to the Valley of the Kings, but in front of you, or nearly in front of you, is Deir el-Bahari, which is a great big cliff, and there is Hatshepsut's temple. And it is absolutely spectacular. It's used for operas today. Well, it was until things changed in Egypt. But it's got big ramps and beautiful steps, and you can go up there, and it's spectacular. It's also a place where a few dozen tourists were murdered not so long ago, during the after Mubarak was deposed in Egypt. So, but it's a spectacular place to visit. And statues of the goddess Hathor and other things. Why am I telling you about this? Well, Senenmut was her chief vizier, and his tomb indicates just how much Egyptians were obsessed, really, with astronomy. And these stars have a dual purpose. One is religious and one is agricultural. So if you look down here, you can just make out these circles. The Egyptians had 3 seasons, Achet, Paret and Shumu, and they were different, they're 4 months each. So the year was divided up into 3 seasons of 4 months. So starting in July, 4-month period, you had the Achet, which is the flood. Nowadays you don't have a flood because you've got the Aswan Dam. So the Egyptians control the water flow through the Nile. But in those days they didn't. So what happens is, this is typical, this is all inside the tomb of Senenmut, on the ceilings and everywhere. And you can see all these details, these are astronomical details as well, about when the season would begin. So each of the 4 circles represents a season, okay? So Achet, Parit, the middle one, is the season of going forth. When the Nile inundation dropped, the level of the Nile fell, people would go, the farmers would go out and do their farming. And you know, all those tombs and pyramids and things were built in Egyptian history were never built, they were built during the year, but mostly they were built during the season of the flood, because it's farmers, not slaves, who actually built them. The general population, people think that the Egyptians had slaves. You don't see stuff in films as ridiculous. I mean, they did have slaves, but nowhere near a civilization like the Romans, for example. So the Egyptians, in fact, they treated their slaves very well, by the evidence seems to be. So during the season of the flood, that's when they built the building. So this tomb was probably no doubt carved out during that time as well. Yeah, so all astronomical. These terms, we don't know how the Egyptians pronounce vowels, by the way. We don't know how they pronounce things, so you get these ridiculous words like mushtiw, you know, or nifernitjer, which means, it refers to a priest, or you know, strange things. We don't know. The only way we approximate pronunciation is through our knowledge of Greek, ancient Greek, because Greeks were in Egypt in the modern period, well, modern for the Egyptian period, time of Ptolemy and so on, and of course we worked out the pronunciations of Rosetta Stone. Really. So this is the goddess Nut, and she swallows. This is a bit of Egyptian astronomy for you. And she swallows the night. Here she is. She swallows the sun. Can you see this little red dot? And it passes through her body. The Egyptians had 9 gods of creation, starting with Ra, and beneath that Shu and Tefnut, which is air and moisture. And those two had 2 children, Geb, god of the earth, and Nut, goddess of the sky. And there she is. And she swallows the sun. Of course, the sun passes through the sky. So she swallows it and gives birth to it in the day. So this is day, and this side is night. And you're looking at the actual ceiling of the tomb. Now, this is by no means the only instance of this sort of decoration. It's everywhere. You can tell he was a wealthy noble, because no one could afford that kind of artwork unless you're wealthy. And of course, who was his patron? None other than the Queen herself, Queen Hatshepsut, the Pharaoh. So, anytime you see a ship like that, it's the bark of Ra. It carries the sun. Ra goes down. He's got horns on him, and he travels through this on this little royal barge through the night before he's born. He rises next day, and when he rises, he's always got wings. If you ever see a picture of a sun disk with wings, that's the sun that's been born the next day. So the Egyptians had this cycle, which was a religious cycle and a daily cycle. So all their activities were depicted in these sorts of wonderful illustrations. And there were also demons, lots of them. Okay. Now let's moving on. We'll come back to Egypt briefly, but so basically, you notice I mentioned earlier we had Eudoxus up here of Cnidus, and he's probably the earliest Greek cartographer of stars, if you like. And the earliest evidence we've got of him is he learned those from the priests of Egypt and introduced this. Is probably after the breakdown of Alexander's empire in the 4th century BC. Alexander died, what, 321 or something. So when his empire broke up, of course, there were Greeks in Egypt, and there they stayed. And Alexandria thrived. Anyway, he published some 2 works, an Optron and Phenomena, and they don't survive. But the Phenomena lives on in a poem by the Greek Aratus. And so, and when Ptolemy actually picked up on this, he criticised the poem, but he then got a lot of his information from there and composed his Almagest, which then became the official ancient Greek catalogue for, well, the official guide on the constellations. And he identified 48, so 21 northern ones, 12 zodiac ones which were constantly visible, of course, because of the ecliptic, because the zodiac constellations are those that are on the level of the plane of the ecliptic. And some southern ones, believe it or not. Now look at this. Now Argo Navis, which has since been broken up into 3 constellations, was there. Aries, Cancer, Argo Navis, Ara, the Altar, Canis Major, Canis Minor. People call those big dog and little dog, but they're not the bigger dog and the lesser dog, Latin officially. So that's a misprint in some books. The Gemini, which I'll tell you a bit about that later. Leo, Libra, Pisces, Sagittarius, Taurus, the zodiac constellations, and down here, Canis Major, Canis Minor, Centaurus, Cetus is a strange one. It's supposed to be a whale, you know, cetacean, but in actual fact it was some horrible, horrific-looking monster which more closely resembles the Kraken, you know, from the Titans. So it was pretty horrific. Corona Australia, so it's really interesting to see what they can see. Now, if you take away your latitude, subtract your latitude from 90 degrees, you'll probably get what amounts to your horizon view from where you are on the Earth. So given that they may be 10, 20 degrees north, they can probably see as far as 60 degrees south, if you were down in Alexandria or somewhere in Egypt. So that's about the limit of what you could see. But of course, later on, when, as you'll see, when people explored, the explorers of the 17th century, all the southern constellations were clearly labelled by them, so discovered by them. During the Islamic Golden Age, from the 8th to the 15th century, a lot of that information further information on astronomy was developed, and of course that's where we get our Arabic names today. So, and the Arabs love to record all this information, from North Africa to Central Asia, Muslim Spain, and later in the Far East and as far as India. A significant number of stars in the sky, like Aldebaran, Alnitak, Alnilam, Zuban el-Ganubi, quite one to pronounce, Altair, are all, of course, anything with AL in front of it, basically, is going to be an Arabic word. Aladad, by the way, is a thing that looks like a sextant. Very interesting. It looks like a primitive set. You can measure angles and all sorts of things from that. So, and I think that's a horizontal line on the celestial sphere. That word there, Akumanta. So, now, don't be overwhelmed. Just a couple of things. From 1600 to 1800, you had all the European exploration. So we've had, in between the Middle Ages, the Arabic knowledge, and the Ottoman Empire and so on, and then you had the Renaissance. And of course, during the Renaissance, Latin and Greek and the classics were rediscovered, and of course became very popular. And people learnt Latin. I mean, it was not just something that was confined to the church. And educated people spoke Latin, could read Latin, and could write Latin. And in fact, a lot of these guys in the Enlightenment from the 17th century onwards were actually like Newton and so on, who wrote his Principia in Latin, learned Latin as a matter of course. So, anyway, back to this. We'll come back to Del Porte in a moment, who worked for the International Astronomy Union and actually framed all the constellations correctly, their coordinates and so on, and their boundaries. But the constellations of the southern sky were not really discovered until you had this age of exploration. From the Babylonians, Arabs and Chinese, or any other culture north of the equator, these southern constellations could not be visible or weren't visible. But as soon as you had people exploring, here are a couple of Dutch explorers, Hoopman and Kayser, they actually catalogued some stars. And then Johan Bayer Star Atlas Uranometria came out in 1603. He added considerably number of constellations, 12 in all: Musca, the Fly, Dorado, the Golden Fish. It's called the Golden Fish, but I always thought it was the Swordfish. But Dorado, El Dorado, so it might have been a golden fish. And also Pisces, Volans, the Flying Fish, and Chameleon. Now another chap from this time, Johann Hevelius, added a few more, Leo Minor and Lynx. And then one of my favourite characters, Lacaille, along with the two Dutch explorers, added most of the constellations after the new and important scientific apparatuses of his time. So some of the constellations became instruments, as we'll see. Quite interesting. From him we gained a number of small faint constellations such as Fornax, the Furnace, Antlia, the Air Pump. Here we go, here are instruments. Horologium, the Pendulum Clock, and Microscopium, the microscope. Lacaille created 13 new constellations while mapping the southern skies from his observatory in South Africa. Now, he actually went to South Africa while his fellow compatriot from France, a guy called Lalande, went to Berlin, and the two of them, using parallax, measured the relative motions of the moon and the distance of the moon and the sun using trigonometry and stuff from two different locations. But I worked out that they were about 5 degrees apart in terms of right ascension. Anyway, they managed to almost on a great line from Cape Town all the way up to Berlin. It's almost exactly in the same line of right ascension. Anyway, they managed to do that. But this fellow's interesting, Lacaille, because not only because he had all these constellations, but when he went there, there's a mountain there called Table Mountain overlooking his observatory, which was down on Table Beach. And that Table Mountain is called Mons Mensa. And of course, hence the constellation Mensa, the table. That's where it comes from. So if you're wondering, it's South African in origin. There it is, there, Table Mountain. Anyway, the other interesting thing is, Lacaille divided the Greek constellation Argo Navis into three parts. The ship of Jason and the Argonauts, that is, into Carina, Vela and Pupus. Carina being the keel, Vela the sail, and Pupus the deck. When we say the keel, we actually mean the whole body of the ship. So it was chopped up into three bits, and it remained that way. It still does today. The story of that is so interesting, and he published that in his Coelum Australis Stelliferum, his starry southern sky, that literally means in Latin. And it was published after his death. Now, just before we go on, the interesting thing about those three, we'll come to that later on, the mythology behind Argo, the ship Argo, Jason the Argonauts, you've heard of Jason the Argonauts, is fantastic. We'll come to that in a minute, so just keep that in mind, and I'll move on quickly. Some constellations were dubbed. People made up constellations to pander to certain famous people, usually kings, or to famous astronomers. So, for example, Harpa Georgii was a constellation in Taurus, replaced the left foot of Taurus, the mouth of Cetus the whale, and the river Eridanus of Johann Bode. Bode is an interesting character too, we'll come across him later. Bode is another cartographer, meant to be a homage to the King George, but of course that died as well, George's heart. These things lost. Felis, well look at that, that's a dud, isn't it? But I love the explanation. Felis was originally created by a French astronomer, Lalande, Lacaille's compatriot who went to Berlin, in 1805 when it was published in his Bibliographie Astronomique. Lalande is quoted as saying, "I am very fond of cats." I love this bit. I'm very fond of it. "I will let this figure scratch on the chart." The starry sky has worried me quite enough in my life, so that now I can have my joke with it. But of course, he created the constellation from the four anti and hydra and all those, but eventually it didn't win favour. But look at all these constellations that were actually, sorry, mine. Look at all these constellations that didn't get anywhere. I mean, some of them, we'll read about a chap in a moment who's invented some horrible ones. What's his name? The English, here it is, noted satirist John Hall invented 13 constellations based on rather unappealing animals such as a toad, a leech, a spider, an earthworm, and a slug. Unfortunately, they never caught on. So, but there's so many of them that didn't make it. Quite interesting, really. Now, I love this one. This fellow, Poniatowski's bull, that's this thing here, was a family on the family coat of arms of the king of Latvia and Poland. And the guy who did this mapping stuck this between a ficus and Aquila. What's his name? Pochobot. Director of the Royal Observatory, now in Vilnius in Lithuania. He invented it to honour his king, Stanislav August Poniatowski. So to honour this Polish king. But it didn't really catch on. Poniatowski's bull, I mean, centuries on, who would think, who was that guy? So some of these things didn't last. So there's another failed constellation, if you like. And over here, I love this one, Charles's Oak. And now Charles II, about Oliver Cromwell and the Reformation, the Civil War in England. During that conflict, I love this bit, Robo Carolinum, an obsolete constellation created by Edmund Halley. In 1679, this constellation was meant to honour King Charles, who is said to have hidden in an oak tree for 24 hours after he was defeated by Cromwell in the Battle of Worcester. The constellation was created out of stars that were part of Argo Navis. So, there you go. Another interesting thing, another failed constellation, didn't catch on. I love these. Here are some other obsolete constellations. Maximilian Hell made this constellation to honour Herschel's telescope, William Herschel, to honour him, William Herschel. And there's his telescope. And that, I believe, is still in the Herschel Museum, William Herschel Museum in Bath in England, which I visited. And telescope's there. It was the original telescope. But that didn't catch on anyway. The constellation was constructed of stars that were once part of Gemini, the Twins, and Auriga, the Charioteer. It first appeared in print in Bode's Atlas, of another cartographer, in 1801, a German fellow. It no longer is considered an official constellation. And then I love this one. William Croswell introduced the flying squirrel, Scurius volans, on his Mercator map of the starry heavens. It looks like a pencil draw. It looks really pathetic, doesn't it? It looks manager of Bullwinkle and Rocky and Bullwinkle. You know, the flying squirrel. What a day. And of course, does anyone know who this is? Antinous was Hadrian, Roman Emperor Hadrian's lover, whom he took everywhere on his travels. Where he died, he drowned in the Nile in Egypt. And so Hadrian had depicted an eagle taken to heaven. Of course, the eagle was a symbol of the Roman Emperor as well, Aquila, famous constellation as well. So there you go, interesting little bit of, if you want to read about that later on, the whole story of Antinous. Now, a bit about the mythology of the constellations. I love this. Can you see that cartoon? Perhaps I'll enlarge it. Let me enlarge it for you. I did want to put a bit of humour in here. Oh, sorry. I'll just escape that for a minute and go back to this and enlarge it so you can see it. And I'll also scroll up a little bit. Oh no, I didn't mean to do that. Hang on. Oh. I'm a bit down too far. There goes Williams again, trying to win support for the Little Bang Theory. Do you know Larson cartoons? I've got a couple more to come. So I'll undo that and soldier on. So there you go. So let's look at the mythology of the constellations. Most of the mythology is, of course, of Greek origin, as we said earlier. Two of the most, I just chose two constellations that are always related to each other, Scorpius rather, and Orion. Because when one is rising, the other is setting. And so we know Orion is a summer constellation because you can see it now. The myths underpinning them were kind of explain why they are where they are. According to Greek mythology, the hunter Orion was the most handsome of men. He was the son of the sea god Sidon and Euryale, the daughter of King Minos of Crete. In Homer's Odyssey, he's described as exceptionally tall and armed with an unbreakable bronze club. In one myth, he fell in love with the Pleiades. Now, you know what the Pleiades are? The seven sisters. The Pleiades and the Hyades, you've heard of the Hyades in Taurus as well, both in Taurus. The Hyades were sort of associated with rains and storms because they were crying all the time because their brother died. And they were half-sisters to the Pleiades. And both of those groups of women were accompanying the goddess Artemis, or Diana as she is in Roman mythology, the goddess of the bow and hunting and so on. She's an earth goddess. Anyway, Orion fell in love with the Pleiades. In fact, he fell in love in particular with Merope, but let's leave that out for a minute. Daughters of Atlas and Pleione. He started pursuing them. Zeus scooped them up and placed them in the sky. This is a short version of it. The Pleiades are represented by the famous star cluster of the same name, the constellation Taurus. Orion can be still seen chasing them. And so here are the Hyades. This V shape is the Hyades, and the Pleiades are down here, the M45, as you can see in this picture. This is around about now too, visible now in the night sky. In another story, he falls in love with Merope, the beautiful daughter of King Oenopon. This is a different Merope, who didn't return his affections. One night he had too much to drink, tried to force himself on her. The king, enraged, put out Orion's eyes and banished him from the land to the island of Chios. Hephaestus felt sorry for Hephaestus, a god of, associated with the sun, I think, banished him, and bronze, I think, as well. Hephaestus felt sorry for him, saw the blind wandering Orion and offered one of his assistants to guide him and to act as his eyes. Eventually, he encountered an oracle that told him he was, if he went east toward the sunrise, his sight would be restored. And he did so, and that miraculously happened. So the constellation Orion has its origins in Sumerian mythology. Now, Sumeria and Babylon were in Mesopotamia. Mesopotamia means the middle of the rivers. Potamos is Greek for river. Have you heard of hippopotamus? Hippo, horse, potamus, river, river horse. So Mesopotamia means the land between the rivers, and that is, of course, modern-day Iraq, where you've got the Tigris and the Euphrates rivers, and Baghdad is just in between the two rivers, where the confluence, where the two come together. Anyway, it goes back to Sumer was in Mesopotamia, and the Epic of Gilgamesh, which I have to study at uni, but I can't remember a thing about it except the big flood, and the hero Gilgamesh. Sumerians associate the story of the hero fighting the bull of heaven, Taurus. Most myths about Orion's death involve a scorpion. So just quickly, if I'll just dwell on this thing, here's the scorpion, opposite end of the sky, of course, setting in the west when Orion's rising in the east. So Orion boasted to the goddess Artemis, the one I just told you about, and her mother, that he could kill anything on earth, and the earth goddess as punishment heard this, Gaia. I think Gaia's an organisation today, isn't it?
Yes.
I'm sure it is, based on the earth goddess. Anyway, she heard this and sent a scorpion which stung the giant to death. In another story, he tried to force himself on Artemis and was the one and she was the one who sent the scorpion. In yet another account of his death, he was stung while trying to save Leto, that's her mother, from the scorpion. All myths of Orion's death share the same outcome. Orion and the scorpion were placed on opposite sides of the sky, so that when the constellation Scorpius rises, Orion's setting below the horizon and so on. So they're forever apart. Now we know it here, and we know parts of the constellation, Orion's belt. It has different names in different cultures. In Spain and Latin America, the stars of the belt are called Las Tres Marias, or the Three Marys. Interesting. In Babylonians knew Orion as, I won't even try to pronounce that, the heavenly shepherd. Egyptians associated Orion with the god Osiris, who was the god of the afterlife, basically. So when people died, they went to the fields of Yaru in Egypt, which was like their version of heaven. And there they gazed upon Osiris. You know. So Osiris was sacred to them, and so they knew the hunter. They also knew about the Sirius, the dog star as it came to be known, Alpha Canis Majoris. Sirius is important because when it appeared, its heliacal rising above the eastern horizon indicated that the Achet, the season of the flood, was about to begin. So Egyptians based that, as soon as they knew that star arose above the horizon, they knew the flood season was about to begin, those 4 months of flooding, the inundation, and then the subsidence. So a very interesting thing about Sirius often appears in Egyptian astronomy as well. Getting on to the Zodiac constellation just quickly, all I want to say about these, apart from the fact that they're well known to the Greeks and appeared in Ptolemy's Almagest in their complete form, the interesting thing is the most important ones are the cardinal signs. So why we call them cardinal signs? Because, you know, we talk about the first point of Aries and Libra straight opposite. They're just where we study our right ascension, our circles, if you like, around the celestial sphere. So they're important for that, and they measure the beginning of seasons. So they indicate the beginning of the season. So, you know, March the, 21st, and September the 20th or 21st mark the two equinoxes. That's what we're talking about here. Now, one last thing, astrology. Now, the Zodiac constellations serve a purpose in terms of astrology. Of course, as we move around the sun, we see different, as we go in our path around here, you can see the Earth going around the sun. You tend to gaze on these constellations because they appear on the same table, if you like, if you think of the ecliptic as a table that the planets do, roughly. And so different times of year we go through different constellations, they become more prominent. So when astrologers say the sun is in Leo, the sun is in your sign, in July or August, that sign is not visible in daytime because of your location. So if I can just, in fact, the next one illustrates that beautifully. If you look down here, so here's Leo, and you can see the sun's going, Earth's moving around the sun. If you look out, the sun is in Leo, and then at different times of year, as we go around, the sun passes through each constellation. So if the sun is in your star sign, that's when your birthday is, basically. Does that make sense? Did I leave out? Yeah, so today's Zodiac constellations are most commonly brought up in the context of astrology. Now, I won't say much about astrology because some of us might believe in astrology, but isn't it awful when you hear people confuse astrology and astronomy? That really gets me. But even the great psychiatrist Jung said that astrology holds some value, mainly as a scientific way of looking at personality types. Because that's what it does, basically. Sort of classifies people with personality types. Oh, you're a Leo, or you're an Aquarius. You've got these traits and those traits. Unlike Chinese astrology, which is much more complex and goes down to the hour you were born, the minutes you were born, the animal of the year you were born. It's really, I don't know if any of you have read any Chinese astrology. It's amazingly complex, I think. So basically, what are the purposes of zodiac constellations? Really, those cardinal points to indicate the equinoxes, and of course, they indicate seasons for us. We know where we are during the time, the course of the year. Capricorn being the start of the year in January, and then of course moving through till the end of the year. You've got Sagittarius for Sagittarians in December. They last a month, basically, the passage of time. Now, what's wrong with these things? What's wrong with them? They don't coincide with other constellations. Why? They don't fit in what we've got because they represent 12 artificial divisions of the night sky. So 12 into 360 is 30 degrees, so you've got 30-degree chunks of sky, which doesn't really work because constellations don't fit into that sort of, the boundaries are quite different, remarkably different, but it's just that it's convenient, I suppose. Just a bit of information. The largest of the 12 zodiac constellations is Virgo, which is also the second largest constellation, I think, what is it? Hydra is the biggest. There's a bit here about the area, so I won't delve into that. Aquarius, Leo, Pisces, and some of the brightest stars in the night sky are also, in the first 10, first 20, are also in the zodiac constellations, and of course would have been noticed long ago. Aldebaran, the brightest star in Taurus, Spica in Virgo, and Taurus in Scorpio, and so on. Okay. I put this up here, these mystical signs. These symbols mostly originate in medieval Byzantine astronomy, but their present forms were created during the European Renaissance. So, another bit of humour. Can you see that little cartoon by Larson? It's just, I won't enlarge it. As an astronomer, these guys have got a texture and they put ink texture around the eyepiece of the telescope, so he's got big black eyes. Oh. They're laughing. Yeah, science humour. Scientists, I love that. Larson's very good at that sort of thing. Right. So, how do constellations work today? In a nutshell, basically, to enable us to find objects. So if you say something is in Virgo, you know which area of the sky you're in. And there are two basic systems we use, the Bayer system and the flamstead designation system, which I'll talk about briefly. But something I didn't realise is how astronomers today group these constellations. They've actually grouped them into certain similarities and traits. For example, these are the northern ones, the Ursa Major family. So all the constellations that are probably within the vicinity of Ursa Major, the Perseus family, the Hercules family. I'm guessing that these have some bearing to the hero Hercules and his labours and so on. Sir Isaac Newton fancifully thought that all the zodiac constellations had to do with Hercules. Like, there was a commonality amongst them, but people thought that was stretching the mark a bit, and that there was no real relationship there. They couldn't sustain that argument. The Orion family, now you know how you've got Orion here, and then you've got down here Monoceros, and then beneath Monoceros you've got Canis Minor with Procyon, the brightest star in that, and then above you've got Canis Major and Sirius. So of course they would call them, and then you've got Lepus as well, the hare. So you've got all those constellations together. The Zodiac family, which we already discussed. The Heavenly Waters family. Now I don't know what. I can understand a dolphin being there, and Eridanus, the celestial river, but Equilaus, the little horse, must be to do with the proximity. The Bayers family, Hydrus, Dorado, Volans, Apis, and so on, Chameleon, Musca, and Lacal. So they're the constellations that they added, I guess. Now, asterism, a bit about asterism. So really, the term asterism is just a more general term than constellation. So it's any pattern of stars. But it can also be part of a constellation, like we say the Iron Pot, or Orion's Belt, or the Sword of Orion, or things like that. So they're all, so the term asterism is used to indicate a subset of stars from a constellation. They make a separate recognised pattern of their own, the Little Dipper in Ursa Major, the Big Dipper is an asterism, and then of course it's a more general term. An asterism may also be a section of a constellation, so Orion's belt, the belt of Orion, whatever. Non-sectional asterisms, for example, the bow and the arrow of Sagittarius, the archer, also make an asterism, and so does, and we'll often heard Steve talk about it, the teapot in Sagittarius, that funny little shape. So that's all an asterism is. So an asterism can be a pattern of stars on its own, or it can be part of a constellation that you've taken out and said, hey, look at this pattern, like the coat hanger. Can you see that all right? The coat hanger, it's got that shape. To us, I think it's upside down, Steve, isn't it?
No.
Is that the right way up here? And it's upside down up in the northern hemisphere. So, yeah, it's in the constellation Vulpecula, the fox.
That's definitely worth chasing down. It's
Beautiful,
pretty,
yes.
Pretty sight.
Very pretty. And in fact, that appeared in one of our astronomy magazines. Yeah, as an ideal. Sorry, Steve, you were going to say?
No, sorry, wide field.
Wide field.
Wide
Yeah.
field view.
Okay, so asterisms range from the large and obvious to the small and even telescopic. A renowned one, the coat hanger, is also called Comet 399, is in the constellation Vulpecula, and it's visible to the naked eye, although stretching it, I reckon, isn't it? About 7th magnitude, maybe? Very bit faint. Okay, where are we? Okay, now you can't read that, I can't either. But that's all 88 constellations. I just had to have them down there with all their names, which is quite interesting. And they're the modern ones, they're the ones we use. So basically, in a nutshell, where do they all come from? From the religious origins, agricultural origins, and their purpose has become then navigation as well, of course, for sailors, and nowadays for locating all sorts of interesting deep sky objects as well, and in basic astronomy. So 36 are found in the northern skies and 52 in the southern constellations. It is. So we've got more constellations now up north. We've also got the best sky, which is beyond dispute. Now, two leading astronomers impacted the way we designate constellations, the stars in constellations rather, and they are Bayer and Flamstead. Now I'll tell you a bit about Flamstead's an interesting character, but Bayer, Johan Bayer, was the first to apply a system where he'd take the brightest stars and he'd say, here are all the first magnitude stars, but of course in those days they didn't have photometers like we have, and they couldn't measure exactly, so if you take all the brightest stars in a constellation, say there are 3 or 4 that look pretty much the same, he'd use his eyesight and say, oh, well that's the brightest, so I'll call that alpha. So he went through the Greek alphabet, alpha, beta, gamma, delta, all the way to omega. But some were left out, didn't use all of them. But once you got through the 24, if there were 50 stars in that constellation, whoa, what do you do then? So you use the Roman alphabet, Romanised letters as well, which I'll explain to you in a moment. So he used that as well. So when you see Alpha Orionis, which is Betelgeuse, right, that's one way of calling Betelgeuse. You can also call it by the Flamstead system, which I'll talk about in a moment. So that's what he did. The only problem is that where he saw a whole lot of stars in the 1 magnitude class, then the next magnitude class, 2nd magnitude, which is 2.5 times fainter, he wasn't able to distinguish the exact brightness of each because they didn't have the technical means to do that. So sometimes beta or gamma in a constellation might be brighter than alpha. You know what I mean? So it doesn't always follow that system. It doesn't work. And sometimes the rules were quite arbitrary. Sometimes he used the alphabet just because things were next to each other, and he thought, oh, that's the next one over here, or he'd go west to east. It's kind of, the rule wasn't applied consistently. But we use it today. So the first and oldest system were proper names, of course, you know, from the Arabic times and the Greeks, you know, the older Bayer and all those. But they're all the typical names. They're the 200 brightest, Betelgeuse, Sirius, Vega. The Arabic name for that is really complex, I discovered. And Antares are all examples of proper names. And then, of course, you had the Arabic names as well. Now, in practice, the traditional names are only universally used for the very brightest stars by astronomers today, and for the small number of slightly less but bright but interesting stars like Algol, Polaris, Mira, and so on. For other naked eye stars, we have the Bayer or Flamstead system, which I've just been talking about. And sometimes you get interesting stars too, like Barnard's star, which has got a modern name. Now, astronomers today make use of a combination of these two methods. So a Bayer designation is a designation by Johan Bayer with a Greek letter followed by the genitive form of the parent constellation name. So say it's Orion. I don't know if you know any Latin, but the genitive form is the second form of a noun. Most English words today are derived from the genitive form of all nouns in Latin. Mensa, 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 mensa. I don't know if you've done any Latin school, but if you're in an English school, you'd be sitting there chanting all these things back in the 19th century, as they used to do. All the declensions of a noun, the 12 endings of a noun. The second ending is the genitive form, the of form. So when you say Alpha Orionis, you're saying Alpha of Orion. Get it? So Alpha of the constellation Orion. So Orionis. So you have to say Orionis. So it's a combination of Greek and Latin. So that's how that's formed. Now, the original Bayer designations comprised 1,564 stars. They appeared in his Uranometria in 1603. However, as the Greek alphabet only has 24, and some constellations visually have more than 50 stars, 50 or more stars, he had to use Latin letters, and he used uppercase A followed by the lowercase b through Z, but he left out J and V for a total of another 24 letters. So that way he could get up to the 50 or so that might be visible within a constellation, to the naked eye, that is. Anyway, yeah, I don't think I'll get any more to that. So good examples are S Carinae, D Centauri, G Scorpio, and so on. N Velorum from Vela, the constellation Vela. The last uppercase letter used in this one is Q. Bayer catalogued only a few stars too far south to be seen from Germany, but later astronomers, Lacard, whom I've talked about earlier, and a guy called Gould, supplemented his catalogue with more southern constellations. Quickly, I won't read you all that. Flamstead was the other chap. Flamstead, you'll know, was Astronomer Royal. What I love about Flamsteed, he worked out the system of using numbers, but what I love is the story behind his cataloguing of stars. His information was stolen, in a sense, by none other than Sir Isaac Newton and Edmund Halley. Because he'd actually observed all these stars and kept the information locked away in the Greenwich Observatory. First of all, there was an incident concerning a comet, I think it was called Kirch, and the comet, and he predicted orbits, and was trying to work on comets, and he kept this information, and they stole it, and of course they published these things in the Royal Society and elsewhere. But the second occasion was far worse, where all of his very accurate, as it turned out, observations of the positions of stars, he just refused to publish them. He kept them locked up in Greenwich. And because Sir Isaac Newton was, I think, president of the Royal Society, or someone high up in the Royal Society at that stage, and Edmund Halley, he was his accomplice, they got his information and they published it without his permission. And he was furious. And they published 400 volumes of his work. And so what he did was, he got 300 of them and burnt them. And said, if Sir Isaac Newton be sensible, I have done him a favour, saying that his data was probably all wrong, but it wasn't actually, as it turned out. He was a darn good astronomer. So I think there are these interesting little conflicts between these. I love these personal stories about astronomers and their conflicts. Anyway, getting back to Flamsteed. So Flamsteed, Astronomer Well, made all his observations, and he used a number system. So a Flamsteed designation is a combination of a number and a constellation name. So instead of Alpha Orionis, you might have 19 Orionis, or one. No, you wouldn't have in that case. You'd have one Orionis. Does that make sense? Or yeah. So, he uniquely identified the stars in the constellation from southern England. His designations for stars were similar to Bayer, except that they used numbers, of course, and the genitive form of the constellation once again, as Bayer had. Flamsteed's designations were assigned to 2,500 stars, 2,554 stars, a bit more than Bayer's. The numbers were originally developed in order of increasing right ascension, I guess from west to east, so increasing right ascension within each constellation, but due to the effects of precession, the Earth's axis, the wobble of the Earth, if you like, they are now slightly out of order in some places. The method of designating stars first appeared in the preliminary version of his, Historia Coelestis Britannica, published by Halley and Newton after, without his approval, which I just told you about. So, the final version of his catalogue left out some numbers, but these were elaborated by Lalande, whom I told you about earlier, the other astronomer, and are the ones that we use today. Where a Bayer designation with a Greek letter does exist for a star, it is usually used in preference to the flamstead one. The flamstead numbers are generally preferred to Bayer designations with Roman letters, however. Examples of well-known stars that are usually referred to by their flamstead numbers are 51 Pegasi, 61 Cygni, and so on. Flamsteed designations are often used instead of Bayer if the latter contains an extra detached number. For example, 55 Cancri is more common than row 1 Cancri, and so on. Okay, so because he was up in his catalogue includes stars visible from Great Britain, stars of the far southern constellations have no flamsteed numbers, which explains a lot. So some stars, such as excuse me, the nearby star 82 Eridani, were named in major southern hemisphere catalogue called Uranometria Argentina by Benjamin Gould, and they've got a G in front of them. It's another guy, another cartographer. So they're called Gold numbers. So there are 52 constellations that primarily use flamsteed designations. And there's just a bit about the Greek alphabet. And if you look at the constellation Orion, you can see here are some numbers up here in different parts, 14, 16, so they're flamsteed numbers, and so on. And you've got the Bayer, of course. So Betelgeuse is Alpha Orionis, they're the Bayer designations, and they're the flamsteed ones. There's a good example. So Regal could be called 19 Orionis if you wanted. Just depending, you know, but I mean officially it might be known by that in flamsteed terms, or in Bayer, Beta Orionis. It should be Alpha Orionis, so I mean Betelgeuse being a variable giant, red giant, you know, it's sometimes faint and so. Yes, sorry. Oh yes, I'll skip along very quickly. Just to finish up, basic techniques, this is the last part of the. I just wanted to say to you, I won't go into any detail, but you know, we all talk in astronomy about aperture fever, and the bigger the telescope, the more the light bucket. It's true in photography as well. The bigger the sensor, the more information you can put into the sensor. CMOS sensors are common in cameras today. They're not as good as CCDs for imaging, but to do that you've got to cool them down, do all sorts of things. But a basic setup is like this with a remote cable, and you can set your focus on infinity use tape. So you can set it up during the day when you've got visible, you know, set your camera up with a remote cable release. You can, some cameras have got lock-up mirrors to reduce vibration, and they've all got bulb or manual settings, which means that some of them have got auto, so you can take 30-second exposures. Set your ISO, that is the speed rating of your camera, to anywhere between 1600 and 3200 ASA or 6400 ASA. Cameras today that have got full frame sensors like that are so good that you can, exposure times of 30 seconds will generate a pretty decent image of the Milky Way. So I'm going to cut this very short. There's some examples there of the different kinds of lenses and setups. By the way, lots of cameras have crop frame sensors, smaller sensors, so they're not as good.
Let's wind up.
Yeah.
Let's wind up.
Okay, so finally, there's a 500 rule. Divide the focal length of your lens by 500 and you'll get how many seconds you should expose for to prevent star trails.